Let's take a look at number 1. A damsel in distress is in distress and is being held captive in a tower. Her knight in shining armor is on the ground below with a ladder. So here's my damsel. She's up here in her little tower, and she's looking down. She's in the tower. The knight is on the ground. So here's my knight down here looking up at her. He's got a ladder, and when the knight stands 15 feet from the base of the tower, so here's the tower, he's standing 15 feet from the base of the tower. We assume that the tower's straight, so it would form a right angle. He looks up at his precious damsel, so he's looking up at her. And it says the angle of elevation to her window is 60 degrees. So here we have a 60-degree angle of elevation. How long does the ladder have to be? So a ladder is at an angle, and we're going to try to climb the ladder and rescue her. So we need to look and see which pieces we have. We have the 60-degree angle, and we have the side adjacent to the 60, and we have the hypotenuse. Adjacent and hypotenuse is cosine. So we have cosine of 60 degrees equals 15 over x. Cosine of 60 is one of those standard trig functions that we should know. So the cosine of 60 is 1/2. And when we do our math, we have x times 1 is x, and 2 times 15 is 30. So my ladder needs to be 30 feet long. So that's problem 1. Problem 2. You are standing in a forest. So here I am. I'm going to draw myself down here. Standing in a forest, you see 2 fire towers on either side of you. So I'm looking this way and I see a fire tower. Looking this way and I see a fire tower. So there's a fire tower there. There's a fire tower there. The angle of elevation to the top of the tower on your left, so if I'm standing facing you, my left would be right here. So the angle of elevation from the left is 34 degrees. And the angle of elevation to the tower on my right is 27 degrees. So there's my picture. Both towers are 40 meters high, so 40 meters. Find the distance between you and each of the towers. I'm going to call this one X and this one Y. And the distance between the towers. So when I finish that, I'm going to want to add those two distances together. So let's see, let's work on Y first. Y is, I have side opposite and I have adjacent. Opposite and adjacent is tangent. So tangent of 34 degrees is 40 over Y. So if I take my calculator and I punch in tangent of 34 degrees, I get roughly 0.6745. And so that's 40 over y. So 0.6745 times y is 0.6745y. Remember, you can do these as a proportion. So if I divide both sides by 0.6745, so 40 divided by 0.6745 comes out to roughly 59.3. So 59.3 feet. That's this. Or meters, sorry, excuse me, meters. On this side, I have side opposite and I have adjacent of the 27 degrees, so that's also tangent. So I'm going to do the same thing. Tangent of 27 degrees is roughly 0.5095. Multiply and I get 0.5095x. Divide both sides by 40, or by 0.5095, and I get x is approximately 40 divided by 0.5095, comes out to roughly 78.5 meters. So this one is 78.5 meters. So if I add those two together to answer the last question, 78.5 plus 59.3 comes out to 137.8 meters. So that's this. So that answers all three questions in that one. So let's go to question 3. Question 3 says, suppose you are flying a kite and it gets caught at the top of the tree. You've let out all 100 feet of string for the kite, and the angle that the string makes with the ground is 85 degrees. So I have this kite at the top of the tree. I have a string going from it that is 100 feet. It's in the top of a tree. The angle that the string makes with the ground is 85 degrees. Instead of worrying about how to get your kite back, you wonder, how tall is that tree? So this is the tree. From my 85 degrees, that's opposite and hypotenuse. Opposite and hypotenuse is sine. So sine of 85 degrees equals x over 100. All I need to do to get an answer is take my calculator and multiply sine of 85. So sine of 85 comes out to 0.9962 if I round. So I'm going to keep all that in my calculator and say times 100. Comes out to 99.62. And let's see what that is in. 99.62 feet in this one. So that's the answer to that one. So let's see question 4. A sailboat's main sail is shaped like a right triangle, and the base is 18 meters long. If it makes an angle of elevation to the top of the sail of 60 degrees, how tall is the sail? So let's go down here and draw another picture. So this is my sail, and it says that it's a right angle. And it says it's shaped like a right triangle, and the base is 18 meters. This is the base on a right triangle. If it makes an angle of elevation to the top of the sail, so here's the top of the sail, angle of elevation would be 60. How tall is the sail? So again, we look at the 60-degree angle. We have opposite and we have adjacent. That would be tangent. So tangent of 60 degrees equals opposite over adjacent. So all I need to do is take my calculator and do tangent of 60 and then times 18. Comes out to roughly 31.2. So roughly 31.2 meters. So that's what I'm doing on all of those practice problems.